Hi, welcome back. Let's do law of sines again. This is the second part. There could be two possible solutions for this, and let's explain how you can do that. If you're given an angle, a side opposite that angle, and then one of the adjacent sides. The other two sides have to be adjacent. Then, if the side opposite the given angle is less than the other side, then there may be two solutions. Let's do one to see how this works out. Here we go. If we're given A is 8, B is 5, and B is 20 degrees, you notice that B is 5 and angle B is 20 degrees, so we're given a side opposite a given angle and another side. The side opposite is smaller than the other side, so there could be two solutions. This is just a quick sketch of what a triangle could look like. This side could also swing the other way and make another triangle. We do that as the second possibility. Let's do the first one first. We're going to use the law of sines. Since we're given A, B, and B, we're going to use A over sine A is B over sine B. Substituting everything in you can, you obtain 8 over sine A is 5 over sine of 20 degrees because angle B is 20 degrees. When you do the sine of 20 degrees, you get 0.3420. Solving this proportion for the sine of A obtains 0.5472. When you do the inverse sine, you get A is 33.2 degrees. To find angle C, because we have B, you take 180 degrees minus the sum of A and B. So C is 180 degrees minus 20 degrees plus 33.2 degrees. 20 plus 33.2 is 53.2. And then when you work that out, you get C, angle C, is 126.8 degrees. Next, let's find side C. All right, we found that angle C is 126.8 degrees. Let's use the law of sines. C over sine C equals B over sine B. We already worked out B over sine of 20 degrees, and we got 5 over 0.3420. C we don't know. Angle C was 126.8 degrees. When you plug in what the sine of 126.8 degrees is as a decimal and solve this proportion for C, we obtain C is 11.7. That's the first solution. Let's see if there's a second triangle that works. Here's the second solution. I redrew the triangle in red with a new angle C prime and a new angle A prime. If we took that side and swung it around, it might hit that spot in an angle different than what we had before. What you do is you always look at the side opposite the given angle, then you look at the other side, and that's the angle of that other side that you're going to change. This is how we change it. A was 33.2 degrees in the first triangle. Now, A prime, which just means another A, we're going to take 180 degrees minus that 33.2 degrees to get 146.8 degrees. C prime then, remember the sum of the angles of a triangle are 180 degrees, is 180 minus our new A and our angle B. 180 minus the 146.8 that we just found, plus 20, that gives us 166.8. From 180 degrees gives us 13.2 degrees. Our new angle C is 13.2 degrees. We need that because we're going to use the law of sines again to find side C. So let's substitute everything we can in. A is 8. Angle A will be 146.8 degrees because that's really our new A or A prime. And then C over sine of 13.2 degrees. And this is really our new C prime. 8 over 0.5476 is C over 0.2284. I just did the sine of the angles. Work this proportion out, you obtain C is 3.3. If there's only one triangle, when you try to do this, to find a new angle C, it won't work. The sum of the two angles will be greater than 180, you'll get a negative angle. That does not work in our case. So it's almost foolproof to see if there's two solutions.